If you don't know what's Ferris wheel, there is a picture provided here on the left. So that's the Ferris wheel. Could you, Zain, please read the question? Zain, you might.
Okay. How can you develop the equation of a
No. This is the question, the one which I'm pointing at. The in black. In black.
tracking a friend, John, who is riding a Ferris wheel? They know that John reached the maximum height of 11 meter at 10 seconds and then reached the minimum height of 1 meter at 55 seconds.
Okay, thank you, Zain. So the question which is here in the textbook, based on this given information, is how can you develop the equation of the sinusoidal function that models John's height above the ground to determine his height at 78 seconds. So whenever you approach a question and you want to model, you want, the first thing which you want to do is to understand what two types of variables you're working with what is going to be the variable or the type of data which would be modeled on the x-axis and which one is going to be modeled on the y-axis. So any ideas about what's going to be on the x-axis in this case?
The time is going to be the x-axis.
Absolutely. And whenever, it's actually the most common thing, whenever we are modeling something, it will be relative to time. Okay, and time, as you remember, independent. It means that it will be always on the x-axis because you remember that x is an independent variable. Right. So what is on what type of variable or what type of quantity is going to be represented on the y-axis?
Height in meters.
Height in meters, absolutely. So if I am sure that each of you rode Ferris wheel at least once in your life, so you understand that when you keep rotating like this, when the wheel keeps rotating like this, you will reach highest point, and then you'll go down, and then you will reach minimum point, and then you will go up again, and so on. So the height is something which is repetitive, right? And it has a pattern, where time is just passing by. Time cannot be stopped. It's not going to repeat itself. It's just going. Okay, so my other question is, what is the minimum height of 1 meter? Okay, where is on the Ferris wheel the rider when it's the minimum height of 1 meter? How do you understand this part?
Ordinary bottom.
Right. So when you just land the Ferris wheel, right, it cannot be exactly on the ground, right? It varies from a wheel to another, how high it is above the ground. So in this particular case, when you board the wheel, it's you find yourself 1 meter off the ground, okay? And the height is 11 meters. So if the height is 11 meters and when the rider is at the top of the wheel and the minimum height is 1 meters, what kind of information can we take from there about the wheel, about the dimensions of the wheel?
We can subtract the maximum from the minimum to know the dimensions of the wheel.
Exactly. What kind of okay, if you subtract 1 meter from 11 meters, you will get 10 meters. What does 10 meters represent relative to the wheel?
Height of the wheel.
Well, there is the wheel doesn't have a height. The wheel is a circle. So
the diameter.
The diameter. Thank you. So diameter of the wheel, based on what's given here, is 10. Okay. So if the diameter of the wheel is 10, then what is the radius of the wheel?
5.
5. Okay. So this. Excuse me. Okay. So this is already, you see, just based on the question, this is the type of information we can take from there. Okay, before we start even thinking about sinusoidal function. So we know that the maximum point is 11. We know that a minimum point is 1. If we know maximum and minimum, what kind of characteristics of a sinusoidal function can we calculate if we know maximum 11 and minimum is 1?
The
The amplitude, yes, and amplitude, already here, we will have discussed something, amplitude in the sinusoidal function. What is it related to in the dimensions of the wheel?
The amplitude and the radius are the exact same value.
Absolutely, thank you. So amplitude in the question, which is related to a motion in a circular way, any circle, any wheel, will be always the radius of that wheel. Very good. So in order to find amplitude, so what is the amplitude, guys?
5.
5. Other than the amplitude, which is A, right? Because remember we're modeling the equation. What else can we find?
Equation of axis.
Equation of axis. So what is the equation of axis?
11 plus 1 divided
Right.
by 2.
Which is?
So it's going to be 6.
6. Okay, now I want you to look at this picture and tell me, what does 6 meters represent on this picture?
The metal part, like the circle that's in the middle, like line.
So the center, absolutely, the center of the wheel, right? So the center of the wheel, this one, it's called axle, right? Also, this part is called axle. So this is 6 meters off the ground, okay? And for our modeling part, it's important to realize that 6 meters is the axis. Okay, great. So this is, if you check the textbook, this is exactly what they did as well. By using minimum maximum, they found amplitude and the axis, equation of the axis, right? Now, the question here is, how can we develop the equation, right? Eventually, like actually sketching is always, is helpful. Okay, because when you sketch, it helps you think about the equation in an easier way. Okay, so this information, the maximum point and the minimum point have been plotted on the coordinate plane. So what are the coordinates of the? What are the two coordinates? Or what are the two ordered pairs which we can use in order to sketch the function? Remember, x is time, y is height. So what are the two ordered pairs given to us in this question?
10, 11, and 55.
Are you sure that you are placing the variables in the right order? Is it, you said 10, 11, right? Okay, thank you.
Yeah.
You said 10, 11, it's correct. So 10, 11, and?
55, 1.
55, 1. Okay, so if you plot those points, 10, 11 here, and 55, 1, this is what you're going to get. So it's important to realize that, or actually I want you to tell me, what part of the cycle of our pattern, right? What part of the period is from maximum to minimum? What portion of the cycle is it? Is it 1/4, 1/3, half, the entire period? From maximum until minimum, what portion of the?
It's half of it.
It's half. Okay, it's very important observation. So if you remember, and if we'll the cosine parent function, right? Then the entire cycle, the entire pattern is from one maximum to another maximum, right? We kept talking about it yesterday. So here, the points which are given are maximum and minimum. So if I know the maximum coordinates and the minimum coordinates, this is already enough for me to conclude what's the period of the function. And this is what you are going to tell me now. So what's the period of the function? Okay, let me help you. So what is half of the period? Which means the distance between the maximum and the minimum, horizontal distance between
45.
45
I believe-
seconds, right? If this is 55 and this is 10, so if you subtract them, you will get 45. So if 45 seconds is the half period, then what's the period?
90.
90. So 90 seconds is the period. Okay, so once we, guys, if you don't understand something, I don't like this silence, like there are two people who are answering the questions and that's it. So I need you to participate. Don't tell me afterwards when you are looking at the question that you don't understand, because now this is the time to understand, okay? So by now we already know that 90 seconds is the period of the function, right? So if we know the period of the function, what value can we determine in terms of our equation A, K, D, and C?
K.
K. Okay, so in order to find K, we remember that this is the formula for period, is 360 over absolute value of K. Since we know that it's 90, so we sub it in and we solve for K, which is 4. Okay, so by now we know A, we know K, and we know C, right? What is left is the shift. So when you look at this sketch, right, you remember that you have to take a decision. Am I modeling sine or cosine? So Amr will tell me which function I'm going to model, sine or cosine. And other
Cosine.
Cosine. Why do you think it's cosine, not sine?
What do you mean?
I mean, why did you take a decision to model it as a cosine? You know that any wave, sinusoidal wave, might be modeled with the help of sine and cosine. So how did you take the decision of cosine?
From the maximum.
Because maximum is given, we know it, okay? We know the maximum point, it's given in the question.
Miss, you're lagging.
Well, I hear you very well. Probably it's your internet issues, not from my end. So the maximum point coordinates are, what is it? 10, 11, right? So then tell me, please, the last part, which is D. What is the D value going to be? And why?
Plus 10.
10.
Positive
No.
10, you mean? Positive 10. D is positive 10. Why, Farah, is it positive 10? Not negative.
Because
The D itself, not the formula. Forget about formula right now. First, you need to determine whether D is positive or negative. Who knows, guys, why D is positive?
Because it didn't start on the y-axis. It
It
started
did. Yeah.
on the x, on the 10 value of the x-axis.
Which is a shift where?
To the right.
To the right. So whenever D is representing the shift to the right, D is positive. And whenever it's representing the shift to the left, then D is negative. So finally, we can conclude that D is positive 10. So here comes your equation, right? So cosine equation with a phase shift of 10. So now, once you have an equation, you can use it. In what way? To answer the question, what is going to be John's height above the ground when 78 seconds have passed? Suggestions, what are we going to do in order to answer this question? I want to find height when I know time. What to do?
instead of X.
Yeah. Yes, Abdurrahman.
I was going to suggest that as well. Or we can look at the graph and see where it intersects.
Well, graph is not a very good idea.
It's not going to be accurate, yeah. You're right.
It's not going to be accurate. So what should we do instead of
I
using?
believe we should, substitute it in the equation and it'll give us the one.
Absolutely, because if you have algebraic model, right, it will definitely be always accurate compared to your manual sketch. So we just need to substitute 78 instead of x, because x is time, and then just calculate, or put all of this on the calculator to get the value of height, 6.17 meters. So after 78 seconds, his height is going to be 6.17 meters above the ground. Okay? So this is the type of process we are going to keep doing for the rest of the unit.